In this video, I'm going to describe a method to solve right-angled trigonometric equations. This is a structured step-by-step method, which has two advantages. The first is you're setting yourself up to get the question right, because the structure helps ensure you don't overlook anything. And the second is that in the pressure of an exam, you've got a well-rehearsed series of steps which you can depend upon. Step 1 is to write out the equations you've memorized. And students often use the strange word SOHCAHTOA, which in turn helps you remember how to write out the equations. Unfortunately, there's no shortcuts here. You have to memorize them and write them down. Step 2, label the triangle. The hypotenuse is opposite the right angle. Now look at the angle you are going to use. In this case, 30 degrees. The side opposite is called, well, no surprises, opposite. The remaining side we call adjacent. Step 3, choose two sides. Tick the two most important sides of the triangle. Now, the most important side of all is the side you've been asked to find, since this is the whole point of the exercise. Next, any side that gives you information is also an important side. So we're told that the length of the hypotenuse is 20 centimeters, so this is valuable. Now, based on the two sides we've chosen, we pick the correct equation. And the only equation that features both opposite and hypotenuse is this equation here. Step 4, we substitute our values into the chosen equation. Now I need to point out that each equation here has three unknowns. This symbol here is called theta, and it's used to represent the angle in all three equations. The other two letters in each equation represent different sides. Now we know the size of the angle is 30 degrees, so we can write this in. Unfortunately, we don't know the length of the opposite side, so we have to leave the symbol O, but we do know the length of the hypotenuse, so we can substitute this value in. Step 5, solve your equation. If you're going to have any difficulty, it's going to be here, and not because you can't do trig, but because you might not be confident solving equations. Deliberately not going to explain it here because I want this video to be about trig, but I do have another video on the YouTube channel which deals just with solving trig equations. I look at this equation and I can see that the unknown is part of a fraction, and in this case I know just what to do. I look at the denominator and multiply both sides by the denominator. I can see that the right hand simplifies, and so I'm just left with the opposite is equal 20 times sine 30. I can put this into my calculator and I get the answer 10 centimeters. Here's another example. Just as before, step 1 is to write down your equations. Do this every time. It will definitely be ingrained in your memory by the time you come to the exam. Step 2, label the triangle. The hypotenuse is opposite the right angle. We then look at the angle that we're going to use, which is this angle, even though it's an unknown. And we know the side opposite this angle is called opposite. And that leaves the adjacent side. Step 3, we choose the two most important sides of the triangle. Now, we haven't been asked to find the length of a side, so there's nothing to tick there. So we go to the next most important side, which is any side that gives us information. And the adjacent side we know is a length of 12 centimeters, and the opposite side is a length of 20 centimeters. Now, the only equation that features both opposite and adjacent is this equation here. Next, we substitute our known values into the equation. We don't know what the angle is, so we have to leave this as theta. But we do know the length of the opposite side is 20. And we know the length of the adjacent side is 12. The last step is to solve the equation. And again, I'm not going to explain in great detail here. If you're not sure, have a look at my other YouTube video. But because this is an unknown angle, we reach for the calculator and press the Shift Tam button, enter our value there, and we'll find that theta, the unknown angle, is equal to 59 degrees. And we're done.